Good morning, everyone. Today, I'm with Johan. We're going to explain about force oscillations. So, first of all, what is force oscillation? So, force oscillation occur when an external periodic force drives an oscillating system, causing it to move at the frequency of the driving force. In context of Fourier series, the idea is to expand the external force into Fourier series and solve the equation for force oscillation.
So this is the picture we'll be using. So there will be the spring here, then there will be the object here. Then it's given that the beta is equal to mu over m, smaller than 0, and for the alpha is for the omega is square root of k per m, smaller than 0, and the ft is equal to 1 over m ft. So here we first draw the FBD. There will be the square, x dot, and x double dot. It's given for the ft. This is the m. So there will be the f spring here. And the f drag. So, here is first. The equation will be what you call it? Sigma f. X is equal to m times x double dot. Anyone can continue it? Okay. So ft will be minus f drag minus f spring is equal to m x double dot. So for the f drag, we use the beta, and for the f spring, we use the alpha. Omega, sorry. So we input this ft minus, first we use mu x dot minus kx is equal to m x double dot. To get the beta and omega, we'll divide it by m. So it will be ft, we take out first, will be mu over m times x plus k over m times x. Wait, forget the x one. Yeah. X double.
Over M.
P is over m here. So this will be our beta, and this will be our omega here. Continue.
Bentuknya.
Oh, malu lupa.
So the final equation will be ft where this is the Fourier function equals to x double dot plus
Beta.
2 beta two beta
Plus
X dot.
omega.
plus omega square x. So here's our governing equation that we will going to use, where ft is the Fourier function, 2 beta is the f drag, and the omega square is the f spring. This is the a0 plus sigma and the force function. Okay. Yeah, so ft is the force function. Next, we'll discuss this. So, we're going to know what is the case of the dam oscillation itself. So how do we know that? First, we substitute the x into the exponent to the power of lambda t. So since the x is x double dot and x dot, the equation is going to be lambda square. To know the case for the oscillations, or like over them, under them. To know the case, sir. So by using the governing equation, we can know about the if the beta, or for what beta value is the case going to be over them, under them. Yes, sir. By using homogeneous equation, sir. Wait. The forcing function, the mass spring system equation. ODE equation.
Like to get the for your total solution, how many components?
Jenis particular solution.
You have to explain that this part coming from the.
Okay.
Okay, you write down on the right side first that x is the solution.
X is
From the part. The part. And this one is solve the whole.
Then we can continue to this, sir.
Yeah, understand.
So to find the homogeneous part, we need to define the lambda first. What is the lambda? And by knowing the lambda, we can know what is the case of the system. On the left side, so the governing equation.
It's when ft is equal to 0, right?
Yes.
Ini kan?
Hmm.
Bukan. When ft is equal to 0, the tail will be
When you
infinity.
want to find out the homogeneous part, you are considering that equation equal to 0. Then you get the homogeneous.
Yes.
It don't go from there straight to here.
Okay, sir.
For that one, you will get the particular.
Okay, sir.
So as make it quick, to make it quick, because we have damping here, okay, the homogeneous part will eventually go to 0. Okay. This is a transient part, whether it is weakly damped or under damped, critically damped or over damped, the homogeneous part will eventually dies out. Okay. And so this is why we are not showing the homogeneous solution for the case of periodic function as the force. But when you have a force like this continuously giving a sinusoid or giving a periodic function, the homogeneous solution will always dies out when you have damping, or when you have the dragging. So in steady state condition, what you will see is the particular solution only. Okay. Can you skip to the next slide? Okay. Then, okay. See, for this homogeneous part, there is a constant in here, beta, beta in here. So exponential of minus beta multiplied by this whole thing, it will dies out. Yeah, it is a fixed formula, and then you have to find out C1 and C2 based on the or in your FM, it's the boundary condition. Right. Coming here, this is the particular solution. And you haven't explained how it goes together.
Yes, sir.
So now we remove our discussion from the homogeneous part. Because when we are using Fourier transform, we are not discussing the homogeneous, we are discussing the particular solution. So you discuss this, how it comes to here.
Okay, sir. So, as our governing equation is the x w dot plus 2 beta x dot plus omega square x equals to ft. In order to find the particular solution, we can use the Fourier series approach, where ft is equals to a0 plus sigma n 1 to infinity an cos nt plus bn sin nt, which already been discussed. Which using the Fourier series approach, we can justify the forcing function because the forcing function is continuous in periodic system, periodic function in time. The ft is a periodic function that continues in time, sir. So we can using we can using the Fourier series approach to expand the calculation.
You cannot Clear for all of you? Okay, give an example. Give an example.
The example for the Fourier series, sir.
No, example of this equation. Why we use this?
So, because it's getting pulled and there's a oscillation that is going to be a periodic continuous in time, then we can use the FT is using a Fourier series approach. So we can input that using a Fourier series equation.
Example of the first example.
No, focus.
Very
Yang this website.
don't need. That's your slide.
Ah.
Your slide.
First.
Gimana?
Ini Bray. Bisa?
Sudah terus.
Jelasin apa aja? Ini kan? Yang mana?
Because we are looking at the
Yang mana?
system.
Is it like this?
And then you see after 1 hour, after 1 hour,
How does the hour
that one likes the molar, right?
Yeah.
Molar.
Bukan cuy.
Apa? Salah, tapi bikinnya periodik jadi
Ini kan?
What's the example? Like this. Okay. The periodic function. But let's say if this is FT, then you find out the Fourier series of this. Okay. Once you get the Fourier series of this, you can get value of A0, AN, and get that. What else? What's the example? What kind of function? X. X.
Yes.
Yeah, this is X. Really.
Yeah.
Step function. Step function.
It's a step function.
What? Repeating step function like this.
Yeah. Up, down, yeah.
So it is, let's say, from 0 to, let's say, 6 to 5. Pulse function.
Yeah.
That one we don't need this. That one because it's homogeneous.
Oh, yeah.
Okay.
For you,
Impulse is like you are facing a sandbag and then you punch. So that sometimes you can punch it. Just go with the transient and after that you give it a transient again. Yeah, we don't need to receive. Alright. Okay, what else? The example you give yesterday. There is not
Fourier series one. Yeah, it's Fourier. Right? Like it.
Yeah, it's like this.
Yeah.
So after that, it goes like this. This is really. So let's say you can express it as a Fourier series. So what's next?
Listen to.
What's
Yes.
Then we expand. What is it? Then we'll be expanding the force of Ft in the Fourier series respect to R. So it will be Ft is equal to infinity n is equal to 0 F n t. So then for the xp we'll seek for the solution of xp in the form of the Fourier series Pt n is equal to 0 x n t. Then we'll be substituting both of them into the ODE using the linear property to arrange the term of ODE in the form. So it will,
Why we can write down
why we can write down Ft.
what's the
Fnt from here, this one.
yeah, how?
The body. Oh, what are you doing?
Can you number your equation? Number your
This one. This
that
one.
one, that one, and that one. Got that. Number one,
I don't.
okay, for equation number 2, what is F0?
A0.
Because it's in 0. And goes from 0 to infinity.
Yes.
So you can put F0. You get what I mean?
Yes, sir.
So F0 is equal to
So,
not F0. F0.
And
Oh. Zero. A zero. F1.
For number 2, okay, for number 2 is you expand equation. You get equation number 2 expanded. Right?
yes, sir.
Expand.
So,
Right?
A0.
No. I'm asking equation. Expanded. Yeah, you take different factor.
Yeah, it's going to be equals to this.
Equation number 2
F1 plus F2.
Ah.
starts from 0, you know.
Oh yeah, F0T plus F1.
X0 of t and then plus. Oh, okay, that is what expanding.
Infinite.
So get plus lah. One F plus. So the one is F0.
The F0 is A0, sir.
Yes. Okay. What is F1?
F1 is the AN cos NT.
What is F1? And it's 1, right?
A1, sir.
I know. A1 cos
Oh, yeah.
B plus
And
B1
no,
sin.
Plus
A1
Yes, F1.
cos T plus D.
Why you put F1 over there? Why is it wrong?
ini A1 aja. Ini aja nggak sih?
Oh, yeah.
When n equals to 1, what it becomes for the 1?
A1 cos T plus B1 cos sin T. B1
One side.
sin T.
T.
Okay. That one up to the n equals to
A infinity cos.
So now you know what you are doing now?
Yes, sir.
Okay.
Sin T.
So why you have equation number 3? Why?
Because what are we going to find the particular solution and not the FT, sir? Because we want to find the particular solution, sir.
Why you have it in that form? Why? Okay, expand again. Expand.
Ini dari nyala kemana?
Okay, now why you have XP that kind of form? Why?
Kenapa pas F0 tidak
Why X?
why F0 is only
So when n is equal to 0, in equation 1, the only subscript when n equal to 0 is just a0. Because the term we have cosine and sine, n starts from 1.
oh
Okay. Now what is the result if you have cosine of 0? What? 1 and then sine of 0.
0.
Okay. So you can also replace this one. You can replace with just this form and start from 0. Imagine if n start from 0, what do you have?
A0.
A0 only. Okay, it's just this one. Same. If you sum n equal to 0 infinity of a and cos what? Nt and sine nt. When n equal to 0, what's the result here? A0 only lah. So which is why this one can be written as A0 plus from 1. Get what I mean? Okay. So which is why this will be the F0. Okay. We make it simple like this so that you can understand. Okay, we only need the A0 for n equal to 0. Now you are confused. Where's n equal to? There, it's there. From the very beginning, it's there. Okay, what's the reason?
Because we're seeking for the particular solution, then we need to define it as x also, sir. We need to define it the fn equals into the x variable also.
I don't know. Can anyone understand what you say? I step it again.
Sorry, sir.
Okay, you look here. Can you remove that? Remove that one. Okay, you see here. You have your x particular d equal to something, right? And then you know that your f is f0 plus f1 plus, there are so many terms on f, right? Now imagine if you have only f0. So I'm taking f0 from here, yeah? Taking f0. The particular solution, I will call it as x0. If I have same system, but my function in here, forcing function is just f1t, then I will call my particular solution as x1. You know what I mean? Then I can continue up to the very large term in here. My particular solution from this alone would be like that. Okay? If this is my input, this is my output. If my input is this one, that will be my output. Get what I mean? Now, if I add all of this, I will get what do we have if we add all of this? Or the sum of xn. Okay. Yeah, I can do this. This is the principle of superposition because the system is linear. Okay. Yeah, the system is linear. This is linear. ODE, linear ODE. Then we can do superposition like this. So you isolate one forcing function, you get an output. You have another forcing function, get different output. You sum all of the output. That will be the output of a system where you have sum of the input. Okay. So the key things when we are discussing the forcing function is that when you are splitting input and output like this. Okay. However, when you are finding out the Fourier series, it's just like the previous discussion. Yeah? But there is no difference. There is no difference with the previous discussion. You still have to find out an, bn, because each of them will become the f0, f1, f2, f3, and etc. Is clear or not why we can write down x particular as a summation of this?
Yeah.
Okay, now what's next?
Uh, Using so
Lowercase. Okay.
oh yes sir.
One X.
Then since we know the x and t is equals to this a0 plus x and t is equals to a0 plus sum of an cos nt plus bn sin nt from n from 1 to infinity. Uh,
Also, you get
an and bn sir.
lowercase. Titles, is that right?
Yes sir.
For the lowercase, that should be capital A and over.
Yes sir.
Then lowercase info. Info.
Yes sir. Hmm. Uh, we need to derivative it first sir. Derivative this first sir.
xn.
The xp equals to t d over dt sum of xn to t.
Yeah.
Right. Di halaman.
to find the an and bn, we need first to take the derivative of the xpt. So it's going to become x p dot t equals to d over dt
Oh, okay.
Which is equals to so the derivative of the sum of x and t is the sum of x and dot t, and then take the second derivative. We find the xp double dot t is also equals to n0 to infinity xn double dot t. Then since we have the governing equation of x double dot plus 2 beta x dot plus x equals to ft, we can substitute it into the governing equation, which become the sigma n equals to 0 until infinity xn double dot t
Plus 2
plus 2
beta
beta 0 plus 6 equals to
sum reboot.
then we can take out the sum. So sum n equals to 0 to infinity is the xn double dot plus 2 beta xn dot t plus omega square-nya lupa.
Oh iya.
Omega square x n t minus f n t equals to 0.
Since the left sense.
Lanjutin.
Apa?
Lanjutin.
So since the left hand side of the equation is identically 0 for all r, then we can result in x double dot nt plus 2 beta x dot nt plus omega square x nt, which will be equal to fnt. think that is. Then we can reduce the equation as x double dot n plus 2 beta x dot n plus omega square xn, which is equal to fn, is equal to an cos nt plus b sin nt pn. This includes the n is equal to 0 in case. So if we assume the b 0 is equal to 0, since the cos 0 is equal to 1, by the linear and the superposition principle, we can cover the particular solution of xp as sum of xn as the xn one. So it will become xpt is equal to infinity n is equal to 0 x and t to that equation.
Suddenly goes into the summation. Why don't you solve the xn first?
The xn will be become x and t will be an cos nt plus bn sin nt. So yeah,
Right. How come the
oh,
that's the thing, you don't have to find a solution.
bagus. Maksudnya ya?
Boleh. Let's just cut it short. Okay. Up to this step is okay lah, because you want to isolate each of the equation n. Each n equation you isolate into here. So you solve for each of the xn. Okay. You are assuming xn equal to 1 sine. Once you assume it, you take the derivative. What's the derivative of that? Then you substitute to here. After that, you solve for the same term, the cosine and the sine. How do we do it? What's the derivative of cos?
Sine. Minus sine.
Minus sine. Minus
an.
n dn. This is sine nt plus n times dn cos nt. The derivative of that cos, right?
Minus n square
a
n cos nt
plus
this is minus again.
and
bn
sin nt.
Okay. So we know that from here the x dot is equal to what? Yeah, there will be cos and sine in terms of cos. So you substitute this one here. Okay. This one is equal to minus n squared
xn.
xn. Now we cannot substitute this. So we have here minus n squared xn plus 2 beta minus n an sin n. Then we have the omega squared n. Sin n. Okay. So each of the xn you substitute it here, and then you equate what's the cosine term and the sine term constant. Yeah, because this one have sine also and cosine also. Eventually, we will have a big term multiplied by cosine nt plus big term multiplied by sine nt, and that is equal to this. Okay, equal to this one. So this big term will be your an, and that big term will be your bn. That's why we arrive here, and this is special case for beta equal to 0. No, n square xn. We replace it already. Okay. But for the x dot, we cannot replace it with xn times something because the form is not like the top one. So this is how we do the. So everything boils down on finding the n and the n. I think that's the end of the discussion for the course. Why don't we get a practice now? Just do a practice. This thing. Give this thing. The black one. Okay. Find out the Fourier series. The constant. Then there is so. Remember the steps taken by Shan and Alfred yesterday. Okay, try also. At the mic. So because everything boils down into the Fourier series, like so now the practice is on finding the Fourier series. Try. Try. Okay, the first step, can you express this as a function? What kind of function is this? Step?
Step unit.
Unit step?
Terus continue. Ano yung function ng gabung-gabung itu? Continue function y. Piecewise.
Where's the unit step? This is 0, you know? 0.
Nggak ada unit ya, Pe?
Oh.
No.
This is half, this is minus half.
Itu X. Ya, we fail. Linear. Fail.
So f of x is equal to, we have 3, okay, 0 when it is from minus pi to minus pi over 2, and this is equal to x, and we have minus pi over 2, and this is 0 again.
Kayak gini.
Pi.
Ini namanya bukan piecewise function.
Not the piecewise.
Oh, piecewise.
Was periodic.
Nice try.
This is a discontinuity here. There is a discontinuity here.
Pasti connected.
Yeah, it's a piecewise function. It's connected.
Ya, berapa function aja digabungin.
So it is continuous, of course, in here. Then you have that one. Yeah, that's continuous. Okay lah, get the indicator function. What is the indicator function best to represent this? Yeah, chai. So I will write it down as a chai. What's the
Jadi yang tengah ini sih.
Minus pi to
Minus
minus
pi
pi,
to-
over 2.
Yang tengah ini.
that is the
Chai ini ya.
mana chai-nya? Where's the chai?
Chai.
Is that chai or x?
X. Ya ini. Oh ini harusnya. Chai itu X gede aja gitu ya. Chai itu X. Masa gue nulis X biasa gue ya.
So it will be from minus pi over 2 to pi over 2 and multiply by x.
Gede.
What minus? Just that one.
Enggak, ini aja. Naik. Slope. Yes. Oke.
Okay, and then we say it is periodic from minus pi to pi. So the period is from minus pi to pi, but then our function is this. Yeah, this is the function. If you want to obtain the Fourier series, then you write down this summation, that is the an cos. Yep. How do you get A0, AN, and BN? You have to first recognize whether it is even or odd. Yeah, to be don't push it to get AN, BN directly. Is it odd function or is it even function? This is odd function. Okay. So we know that this one odd. Okay. Because this is odd function, then which one is 0? This one will be 0, yeah. Okay. So fx is just summation, just the bn cosine. Oh, sine. This is sine. Sorry. Bn sine nt.
Okay.
Bn sine nt. And what is bn? Bn will be
1 over 2, but
1 over 2.
1 over 5.
Ah?
We use the L.
Yeah, we know that the period is 2 pi. So
is half of,
L will be pi.
yeah, half of E.
1 over 2.
We integrate from minus pi to pi. F of x sine
Pi.
this one. What do we have here? 1 over 2 times pi. Is this correct over here? Sine n pi.
Are we going to use the 2 pi or the 2L? Or the
2L will be 2 pi. So you replace everything with the pi. L will be pi. Okay, so what is this? Is this correct? Huh? Nx. Oh yeah, sine nx. Yeah. We don't have the x there. Sine nx dx. Okay. Fx is odd. Okay. Odd times an odd function. Sine is odd function, right? So
even.
become even. So which is why this is from 0 to pi. You multiply by 2, yeah. Fx of sine nx dx. Okay, how do you integrate this?
Oh, jadi cosine.
everything s squared over 2 times cosine n times n. Enggak ada times.
Ini
Fx-nya kan x doang.
chain rule. Oh iya ini. Di atas ini.
0 to pi.
Sorry, this is half pi. Yeah.
Yeah.
0 to
If I don't put here half pi, it won't be x. Okay. Yeah, it won't be x. So your bn will be integral. Sorry. 1 over pi, 0 to pi, and this is the x multiplied by the indicator function. Now indicator function is x already, so we don't have to write down that. Sorry. Indicator function from 0 to pi over 2. Okay, and then sine nx dx like this.
Isn't it only x?
We multiply by 2 already, right? Is it what?
The chi is only x.
Chi is x. Yeah.
Oh, tulis dua kali. Yeah, x times x.
No. This one is to let us know that the function is valued x when x is equal to 0 to pi over 2.
Oh.
Beyond that, it is 0. So because of this, what we write down is that 1 over pi, 0 to pi over 2. This is x sine and x dx. Okay, and then plus from pi over 2 to pi 0 ya. Okay. So your integration is only done here. Yes.
Itu bisa jadi kali 2. Jadi ini maka 0 dan 0 to
1 over pi. Oh yeah, sorry. This one should be 1 over pi. Yeah. I made a mistake here. This is 1 over pi, and this is 2 over pi.
Still confused. Is that the period or the one?
This one?
Yeah.
Half period.
Half period.
Yeah.
Okay.
Kalau itu tab 2.
1 over half period.
Oh.
So this is 2. Okay. Now you have to integrate x sine and x dx.
L.
Use this integration by part.
Integration by part. Karena X.
Yep.
Yeah.
If I use this u, I will use u equal to x, and then my dv is sine and x. Why do I choose this? Because when this is the case, then what is du? Du will be just 1. Okay, and then this integration, it will be just now u times v. Yeah, it will be u multiplied by 1 over n cosine nx, but this is minus. Correct? And then minus integral of sine nx dx. So the integration is simply just on the sine. Oh, this is x. Because u is equal to x. Okay. Then you have to take the limit. Of course, everything will be from 0 to pi over 2. This is also from 0 to pi over 2. Then everything will multiply by 2 over pi. Yeah. Any question on this? So next week we will start the Sturm-Liouville problems. For the final exam, from Fourier series itself, there will be 3 parts. Okay. The first problem is about finding Fourier series of a periodic function. The second one will be the Sturm-Liouville problem. The third one will be the Fourier transform. Okay. So why we discuss Fourier series a lot? Because that will be the basic for our next basically the Sturm-Liouville and Fourier transform. You need to have a good basic in the Fourier series. So which is why we discuss it until 3 meetings. So next week we will finish Sturm reveal and also Fourier transform next week.